Last time we looked at section 4.1 divisibility, we looked at a bunch of different things, and we are at the point where we're looking at example number 4. All right, so example number 4 talks about a number being divisible. So we have 24, and 24 is able to divide m. The question is, what other numbers must also divide m? Any ideas? 2? Definitely 2. So why do you think 2 would work?
Because 2 divides m.
2 divides 24. You bet. Something else. 4. How come, Emma?
It's a factor, it's a multiple.
Yep, you were right the first time. Factor. It's a factor of 24. You're right. Okay, what else? 6. Okay, so I'm going to actually write these kind of like this. 6. I agree. 6 is a factor. You said 3, Valerie. Same reason, right? And 8. And 12. Any idea why I've written them the way I have? Yeah, I wrote them in pairs. It helps us to keep track and make sure we didn't forget any, right? So 2 times 12 is 24, 4 times 6 is 24, 3 times 8 is 24. Have I missed anything? There's one I've missed. 1. Yeah, basically the 1 and the 24. I don't necessarily need to write 24 down, but it is the other, sort of counterpart to the number 24 for factoring. Yep, those are the numbers. So an additional 7 numbers would actually divide m as well. And you said it exactly the right way. I mean, multiple of you said it the same way. If the number divides 24, then it's going to divide anything that 24 divides. And that's what we were looking for. So good job on that. All right. What we're going to do on number 5 is we're going to fill in the blank. We're going to decide what numbers could go in the blank so that we make our value, this 543,220 something, actually divide by the number 2, 3, and 6. So what number could go in the blank so that that number, that 6-digit number, will end up being divisible by 2?
Even number.
Any even number. So can you tell me what I would include?
0, 2, 4, 6, 8.
0, 2, 4, 6, and 8. Any of those will make the number even at the end, right? They'll make it an even number, which will then make it divisible by 2. How would I find numbers that make it divisible by 3? So we need to sort of take a step back. I'll do it over here to the side. We need to add up, Valerie said, the numbers that are there. So 5 plus 4 plus 3 plus 2 plus 2. Oops.
16.
And you get 16. So is 16 divisible by 3 already? Nope, it's not. So I can't put a 0 in the last spot, right? Because then I'd still have 16. So what's the smallest thing I could put in that spot?
5.
Is that the smallest?
No,
2 first. A 2 would work. But then I agree with you. A 5 would also work. If I put a 2 in there, I'd end up with 18 as my sum. If I put a 5 in there, I'd end up with 21 as my sum. And those numbers are both divisible by 3. What else could I put in?
8.
An 8. And if I put in an 8, I would get 24. And that's divisible by 3. Are you good?
Yeah.
Okay. There's actually another cool thing that's going on here. Do you see the relationship between these numbers? They're all 3 apart, which should make sense, right? Once I find one of them, I should be able to add or subtract 3 to find any of the rest. And that works with the factor 9 as well, right? We would do the same kind of a thing. We would add the numbers together to find the value we need to add to it to be divisible by 9. So then, what number would need to go in the blank to make number or numbers to make it divisible by 6?
2 and 8.
Okay, 2 and 8. Why?
Because it's both. It's a factor of 2.
Yeah, no, you're right. It's in the list for both 2 and 3, right? And in order to be divisible by 6, it's got to be divisible by both 2 and 3. So those are the numbers that occur in both of my lists. All right. Let's take a look at a couple of questions that would be sort of C, like section C kind of questions for us. Answer the following, justify your answer. If a number is divisible by 5, can it be divisible by 10? Yes. So the first one says, can it be? And the answer is yes. Must it be? No. So can it be? Can you give me an example?
28.
20. 20 is divisible by 5, and it's also divisible by 10. So must it be? Give me a counterexample. Yeah, 25. 25 is divisible by 5, not divisible by 10. Very good. How about the other way around? If a number is divisible by 10, can it be divisible by 5? Yes. Must it be?
No. Yes.
Yes. So the answer to both of these is yes. So since it must be, it obviously can be. So let's talk about why. Why in the world must that work?
Because 5 is divisible by 0 or 5 or 10 also is divisible by 0.
Okay, exactly, Danielle. I'm going to reverse what you said, like the order of it, but you've got the exact right idea. So if a number is divisible by 10, what do we know has to be true? It has to end in a 0, right. So for the number to be divisible by 10, right here, it must end in 0. That was our divisibility fact about tens, right? If it's divisible, if it ends in 0, it's divisible by 10. If it's divisible by 10, it ends in 0. It goes back and forth. It must end in 0. And if it ends in 0, it's divisible by 5. It's not the only thing that's divisible by 5, right? But it does divide by 5. It's half of the divisibility rule for 5. One of the two facts that can be present. All right, example 7 is a cute one. I feel like it's one of those like trick things that, people give you as a brain teaser or something like that. So let's take a look at it. A number in which each digit, except 0, appears exactly 3 times is divisible by 3. For example, 777,555,222 and 414,143,313 are divisible by 3. Why?
Because, it's said 3 times, so it's basically multiplying.
Yeah. Okay, so Valerie's exactly right. So each number, that's a number sign, not a hashtag. Just FYI. Each number is there 3 times. And 3 times that number is divisible by 3. Right? And we actually saw this earlier. The sum of values divisible by 3 are divisible by 3. We actually saw that when we talked about closure, right? The list of multiples of 3 are closed because if you add 2 numbers that are divisible by 3, you get another number divisible by 3. And it's not special about 3s. That fact's actually true for any multiple number list you would want to use. So when I have 3 7s, I'm going to get 21. And I have 3 5s, I'm going to get 15. And I have 3 2s, I'm going to get 6. 21 and 15 and 6 each individually are divisible by 3, so their sum is going to be divisible by 3. That's what we just said with those specific numbers in mind. Does that make sense? Okay. Part B asks the question in the other order. Must this statement be true in order for a number to be divisible by 3? No. Can you give me a counterexample?
15.
Right. The number 15 itself does not have any duplicates of anything, right? 15 doesn't have this structure, we'll say. But 3 divides 15. Do you remember that notation, that vertical bar? 3 does divide 15.
Works for 32.
Yeah, it works for the number 3 itself, you bet. Any questions on that?